Preparing for a technology interviews at Accenture interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. Tell me about yourself and why you want to join Accenture Technology. I am a software engineer with experience building reliable applications and solving problems collaboratively. My strongest areas are Java, SQL, REST APIs, and cloud fundamentals, supported by hands-on projects. I want to join Accenture because it combines engineering with business transformation across different industries. That environment would expose me to varied technologies and clients while letting me contribute disciplined development, clear communication, and continuous learning. I am especially interested in growing into someone who can translate business needs into scalable solutions. While answering, connect your education or experience to technology delivery, mention relevant skills, show awareness of Accenture's consulting model, and explain how collaboration, learning, and client impact motivate your application. Question 2. How would you explain object-oriented programming to a non-technical client? I would compare object-oriented programming to a business organized around responsibilities. A customer object stores customer information and exposes actions such as placing an order while hiding internal details. Encapsulation protects data, inheritance can share common behavior, and polymorphism lets different objects respond to the same request appropriately. In practice, these ideas make large applications easier to extend and test. I would avoid jargon initially, then connect the analogy to the client's actual domain and system requirements. Make sure to cover classes, objects, encapsulation, inheritance, and polymorphism using a simple business analogy, then explain how these principles improve maintainability, reuse, testing, and communication within delivery teams. Question 3. What is the difference between an interface and an abstract class in Java? An interface defines a contract that unrelated classes can implement, whereas an abstract class provides a shared base with state, constructors, and partially implemented behavior. A Java class can implement multiple interfaces but extend only one class. I use interfaces when I want replaceable implementations, such as different payment providers. I choose an abstract class when subclasses genuinely share lifecycle logic or protected data. The decision should reflect a stable capability or a meaningful inheritance relationship, not convenience alone. In your answer, distinguish contracts from shared implementation, discuss multiple interface inheritance, constructors and state in abstract classes, default methods, and explain how you would choose based on coupling and extensibility. Question 4. How would you troubleshoot a production application that suddenly became slow? I would first assess impact, establish an incident owner, and communicate status clearly. Then I would compare latency, error rate, traffic, CPU, memory, and database metrics with a healthy baseline. Distributed traces and logs would help isolate whether the issue followed a deployment, dependency, query, or capacity change. If a recent release is strongly correlated, I would roll it back safely. After recovery, I would document the root cause, add monitoring or tests, and review prevention actions with the team. Be sure to mention incident prioritization, monitoring, recent deployments, infrastructure metrics, logs, traces, database performance, rollback decisions, communication, and permanent corrective actions after service restoration. Question 5. What is normalization in databases, and when might you denormalize? Normalization organizes data to reduce duplication and update anomalies. For example, customer details should usually live in one customer table rather than being repeated across every order. First, second, and third normal forms progressively remove repeating groups and dependencies. I would denormalize when measured read performance or reporting needs justify duplicated data, such as storing an order summary. That choice increases write complexity and consistency risk, so I would document ownership, synchronization strategy, and performance evidence. Focus on reducing redundancy, insert, update, delete anomalies, first through third normal forms, join costs, read performance, reporting workloads, and the importance of measuring before intentionally duplicating data. Question 6. Write an approach to find duplicate values in an integer array. I would scan the array once using a hash set. For each value, I would check whether it already exists. If it does, I would record or return it, otherwise I would insert it. This gives average O, n, time and O, n, additional space. If modifying the input is acceptable and memory is limited, sorting provides O, n log n, time with minimal extra space. I would also clarify whether the requirement is to return one duplicate or all distinct duplicates. In your answer, explain the hash set approach, time and space complexity, handling of null or empty input where relevant, alternatives such as sorting, and how constraints influence the implementation choice. Question 7. How do you compare REST and SOAP when designing an integration for an enterprise client? REST commonly uses HTTP resources and JSON, making it lightweight and convenient for web and mobile clients. SOAP is a formal XML-based protocol with strict contracts and mature standards for security, transactions, and reliable messaging. I would choose based on the client context rather than popularity. For a legacy banking integration requiring WS security and formal guarantees, SOAP may fit better. For a scalable public service with simpler interactions, REST is usually easier to consume and operate. Cover communication style, data formats, contracts, security, reliability, tooling, compatibility, performance, and how regulatory or legacy system requirements may make SOAP preferable despite REST's simplicity. Question 8. What steps would you follow to secure a REST API? I would enforce HTTPS, authenticate callers with a suitable mechanism such as OAuth 2.0, and authorize every resource operation using roles or attributes. Input validation, parameterized queries, output encoding, and strict content types reduce injection and data exposure risks. I would protect secrets through a vault, rotate credentials, apply rate limits, and log security events without recording tokens or personal data. Finally, I would scan dependencies, test abuse cases, and review the API against a threat model. Make sure to discuss TLS, authentication, authorization, input validation, token handling, rate limiting, secure headers, secrets management, logging without sensitive data, dependency updates, and threat modeling. Question 9. Explain the difference between processes and threads, and when you would use each. A process has its own memory space and operating system resources, while threads share memory within a process. Processes provide stronger isolation but communicate more expensively. Threads are lighter and efficient for related tasks, though shared state introduces synchronization risks. I would use threads for concurrent I/O, such as handling many requests, and processes for isolation or CPU parallelism when the runtime limits thread execution. The choice also depends on failure containment, workload characteristics, and operational complexity. Discuss memory isolation, communication overhead, scheduling, failure boundaries, concurrency, synchronization, I/O workloads, CPU-bound work, and why language runtime limitations can affect thread-based parallelism. Question 10. How would you design a scalable file upload service for an Accenture client? I would authenticate the user, validate metadata, and issue a short-lived signed upload URL so large files move directly to object storage instead of through the application server. An event would trigger asynchronous virus scanning and metadata processing, with status stored in a database. I would encrypt data in transit and at rest, isolate tenants, enforce size and type policies, and use retries with dead letter handling. Monitoring would track upload failures, scan results, storage costs, and retention compliance. Cover direct object storage uploads, metadata, authentication, size and type validation, malware scanning, asynchronous processing, retries, monitoring, retention, encryption, and tenant isolation for enterprise customers. Question 11. What is the purpose of CI/CD, and how would you improve a weak pipeline? CI/CD automates the path from code change to validated and safely released software. I would inspect the current pipeline for slow stages, missing tests, manual approvals, unreliable environments, and weak rollback capability. Then I would add reproducible builds, unit and integration testing, static analysis, dependency scanning, versioned artifacts, and deployment to environments through the same process. For production, canary or blue-green releases reduce risk. Pipeline metrics such as lead time, failure rate, and recovery time would guide improvement. In your answer, mention automated builds, unit and integration tests, quality gates, artifact versioning, security scanning, environment promotion, rollback, deployment strategies, and feedback speed. Question 12. What is cloud computing, and how would you choose between IaaS, PaaS, and SaaS? IaaS provides virtualized compute, storage, and networking, giving control but leaving more operations to the client. PaaS manages the runtime and infrastructure so teams can focus on application code. SaaS delivers a complete application with the least operational responsibility. I would choose IaaS for specialized control or migration constraints, PaaS for faster application delivery, and SaaS for standardized business capabilities. Security, compliance, integration, cost, vendor lock-in, and internal skills must shape the decision. Explain shared responsibility, control versus operational effort, infrastructure examples, managed platforms, complete applications, cost, compliance, customization, portability, and the client's capability to operate technology. Question 13. How would you optimize a SQL query that is taking too long? I would reproduce the problem with representative data and inspect the execution plan before changing SQL. I would check for missing or ineffective indexes, unnecessary columns, expensive joins, functions on indexed fields, poor cardinality estimates, and excessive result sets. I might rewrite the query, add a composite index, improve pagination, or refresh statistics. I would also investigate locks and connection behavior. After each change, I would compare latency and resource usage, ensuring the improvement does not harm writes or other workloads. Be sure to cover execution plans, indexes, joins, filtering, selected columns, statistics, pagination, data volume, parameterization, lock contention, and validating improvements with realistic measurements. Question 14. Describe a time you disagreed with a teammate and how you resolved it. During a project, a teammate preferred adding a new framework, while I favored extending our existing service because the deadline was tight. I first asked about their concerns and learned they were worried about maintainability. We compared both options against delivery time, supportability, and future scale, then built a small prototype. The evidence supported a simpler extension with clearer boundaries. I documented the decision, thanked my teammate for raising the concern, and later revisited the design after release. Focus on respectful communication, understanding the other perspective, objective evidence, customer impact, experiments, compromise, ownership, and what you learned rather than presenting conflict as a personal dispute. Question 15. What is the difference between unit, integration, and end-to-end testing? Unit tests validate one component in isolation and are fast, making them useful for business rules. Integration tests verify collaboration with databases, queues, or services, exposing configuration and contract problems. End-to-end tests exercise a complete user journey and provide confidence in production-like behavior, but they are slower and more fragile. I prefer many focused unit tests, targeted integration and contract tests, and a small set of valuable end-to-end scenarios. This balance improves feedback speed without sacrificing realistic coverage. Cover testing scope, isolation, speed, dependencies, defect localization, test pyramid principles, mocks, contract tests, and how a balanced suite supports reliable enterprise delivery. Question 16. How do you handle a project requirement that is ambiguous or constantly changing? I would not begin implementation based on assumptions alone. I would identify stakeholders, ask targeted questions, and convert the requirement into user stories with measurable acceptance criteria. If uncertainty remains, I would create a small prototype or spike to expose it quickly. I would record assumptions and assess the impact of changes on scope, cost, security, and schedule. Short iterations, demonstrations, and regular stakeholder feedback help the team deliver useful increments while keeping decisions transparent. Mention clarification workshops, assumptions, acceptance criteria, prioritization, prototypes, traceability, change impact, stakeholder communication, iterative delivery, and avoiding development based on unverified interpretations. Question 17. What is a microservice, and when should a team avoid using microservices? A microservice is a relatively independent service aligned with a business capability, owning its code and often its data. It can scale and deploy separately, but introduces network failures, distributed tracing, operational overhead, and harder consistency problems. I would avoid microservices for a small team, an early product with uncertain boundaries, or a simple system where deployment independence has little value. A modular monolith can preserve clean boundaries while remaining easier to test, deploy, and operate. Discuss independent deployment, bounded contexts, ownership, network calls, observability, data consistency, operational maturity, team size, deployment frequency, and why modular monoliths may be more appropriate initially. Question 18. How would you prevent race conditions when multiple requests update the same record? A race condition can cause one update to override another because both requests read stale state. For low contention, I would use optimistic locking with a version column and reject or retry when the version changes. For highly contended, short transactions, pessimistic row locks may be appropriate. Atomic database updates and suitable isolation levels also help. I would make retries safe through idempotency and return a clear conflict response when the business process requires user resolution rather than silent overriding. In your answer, explain lost updates, transactions, optimistic and pessimistic locking, atomic operations, isolation levels, retries, idempotency, and choosing based on contention and business correctness. Question 19. How do you ensure quality when working under a tight delivery deadline? I would align with stakeholders on the smallest valuable scope and identify risks early, especially security, data loss, and critical business paths. I would protect essential unit and integration tests, use code review, and automate validation through C rather than remove quality gates blindly. Lower risk enhancements can be deferred with explicit ownership. Frequent demonstrations reveal misunderstandings sooner. If a temporary compromise is necessary, I would document the technical debt, define a follow-up milestone, and communicate its operational consequences. Focus on risk-based prioritization, minimum viable scope, automated tests, code review, continuous integration, transparent trade-offs, defect prevention, stakeholder alignment, and avoiding shortcuts that create hidden operational debt. Question 20. What questions would you ask before starting a technology solution for a client? I would start by asking what business outcome the client needs and how success will be measured. Then I would understand users, workflows, pain points, existing architecture, integrations, data quality, expected scale, security and compliance obligations, budget, timeline, and operational ownership. I would identify decision makers and constraints before proposing technology. This discovery prevents solving the wrong problem and creates a shared baseline. I would finish by confirming assumptions, priorities, risks, and the next validation step. Be sure to mention business outcomes, users, current architecture, constraints, data, integrations, security, compliance, scale, success metrics, timeline, budget, support model, and stakeholder decision ownership. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.